Oh hey, I didn't see you there. Welcome to the physics of motion on a snowmobile. Over the past few months in Miss Franklin's physics class, we looked at a number of units including light, sound, magnetism, and electricity. But today, me, Braden, and Mike, or rather Mike, Braden, and I, will be looking at a specific unit, the physics of motion on a snowmobile. Let's get into it today. Alright, so today in the motion unit we'll be looking at a variety of different aspects. The first one is speed. What we've done today is we've measured out a long track in Mike's backyard, which is 450 meters long. On go, Mike's going to run that track as fast as he can, and we're going to take his time and use it in the equation V equals D over T, and we're going to find out what his constant speed was. And we've actually instructed Mike to take a constant speed from the initial point, which is this snowmobile behind me, to the point where Braden is, all the way down the field, 450 meters. So when I give Mike the go, we are going to start, so let's get into it today. Alright, so there Mike is up there, and when Mike hits this snowmobile down here, that's the initial point from 450 meters, that's where the 450 meters starts, all the way down there to Braden. Let me see if I can show him to you. He is all the way down there on his quad. There he is right there. So, when I give Mike the go ahead, we will begin this experiment.
According to our physics textbook, velocity equals distance over time. From this exact spot, Mike traveled 450 meters in 12 seconds. That equals, in meters per second, 37.5 or 130 kilometers an hour.
Alright, so now we've finished up speed. Now we're going to work on distance. The equation for distance is d equals v times t, which is velocity times the time in seconds, which is what we'll be using. Now what I'm going to do is I'm going to rip on a drag in Mike's backyard at about a steady 80 kilometers an hour. What Braden's going to do is he's going to time it, and then we'll be able to tell you how long that strip is in meters after calculating the speed using the equation d equals v times t. So let's get started today. Now during that strip, I went at about 80 kilometers an hour, which is in turn 22 meters a second. Now using the equation d equals v times t, which can be found in your physics textbook, we can substitute v in for 22 meters a second and t in for 6 seconds, because I did it in 6 seconds. Now 22 times 6, d equals 132 meters. So that means that that strip I just went along on the snowmobile was 132 meters long.
Now we are going to do time, and as you found in your physics textbook, the equation for time is t equals d over v. And I'm going to do a 450 meter stretch, and it will be at 22 meters a second, or 80 kilometers an hour. Can you find the time?
It'd be sick if you wiped out though, because you get all the...
Oh yeah. Okay, so now we finished time. Now, to be honest with you, that run really wasn't necessary, because we knew Mike's distance and we knew the speed that he was going to be traveling at. And we didn't use stopwatches. What we're going to use is the equation t equals d over v, which can be found in your physics textbook, to determine Mike's time. Now, the distance was 450 meters, and the velocity that Mike was traveling at was 80 kilometers an hour, or 22 meters a second. Now, given that information, we can do d over v, which is 450 meters over 22 meters per second. That will give us 20 seconds. That was Mike's time. Now we're going to be taking a further look into acceleration. Now, as defined in your physics textbook, acceleration can be found by using the equation A equals the change in velocity, which is v2 minus v1 over t. Now, v2 is the final velocity, and v1 is the initial velocity. For this experiment, what we're going to be doing is Braden's going to run a strip that we actually don't even need to know the distance. All we need to know is his initial velocity, which is going to be 50 kilometers an hour, and his final velocity, which is going to be 80 kilometers an hour. Now, given that, we can do A equals V over T, and we can determine his velocity. Now, what we're going to do is we're actually going to time it, because that is one variable that we don't know what is going to happen. So A equals V2 minus V1 divided by T. Let's get to it. So now, after Braden's run, we can now determine what his acceleration was. His initial velocity was 50 kilometers an hour, or 13 meters per second. His final velocity, 80 kilometers an hour, or 22 meters per second. Now we have to determine the change in velocity. By that, we can do v2 minus v1, and that will give us the change. So the change in velocity equals 9. So now what we can do is we can sub it into the equation A equals V over T, the change in velocity over time. His time was 9 seconds he did that strip in. So the acceleration was 1 meter per second squared. Oh hey, how are you? You see this down here? When this wheel spins, it creates heat. Also, energy and friction. It's what it uses to catch traction on the ground. Braden here is going to demonstrate different forms of traction on the road and traction on the ice or snow with these bad boy wheels right here. Now, different surfaces have different amounts of friction. As you just saw, Braden was doing donuts on Mike's driveway. Mike's driveway is covered in ice and snow, which is very slippery and has very little friction. So it was very hard for Braden to get traction, which made it easy for him to do donuts. Now what we're going to look at is the road which Mike's house sits on. Lots of traction, and Braden's not going to be able to do a donut. Let's check this out.
My sled sometimes slips on ice. It is because it is missing one key ingredient on the track.
That key ingredient that Mike's sled is missing is called metal studs. These here increase the chance of non-slippage and let you have a lot more traction when you're on ice surfaces. These metal studs increase your traction and your friction, therefore letting you go faster on ice surfaces. Now we hope y'all enjoyed our demonstrations on the physics of motion.
All of these equations and physics are used in everyday snowmobiling on the trails.
Hope you guys had fun tonight. Boys, let's go for a ride.
Let's do it.